Hello friends, welcome back to this tutorial series of Jetpack Compose, and in this tutorial we are going to learn about lazy layouts in Jetpack Compose. So this tutorial is both important as well as interesting because it allows us to arrange our layouts in the way we want plus in an optimized way. So we'll be seeing about lazy layout, lazy column, lazy row and lazy grids as well in this video. So let's get started. So here I am in an Android Studio project and I have created a separate file LazyColumn demo and I also a function, a composable function, LazyColumn practice. Here we will be seeing how to implement LazyColumn. Before implementing LazyColumn, let me show you implementing the thing which I wanted to implement with the normal column. For int, sorry, not int, in 1 to 100, and I just want to show a text here showing element $I. Means element 1, 2, 3, 4 will be shown. I wanted to show it like a list. Yeah, the view is generated. I just wanted to apply a modifier of fill max size here. Modifier not fill max size. Okay, and this is the thing I wanted to achieve. So now the problem here is, yeah, we are able to see all the elements here, though we are only able to see elements 52 here, but we are not able to scroll here. Even if I have started the interactive mode, I am not scroll here. I am not able to scroll here. We also need to add a scroll behavior here. So this is the one problem with this normal column. Another one is here the text, this loop is iterating 100 times, and 100 times this text composable it being composed. But here 52 elements we are seeing, but all the 100 elements are there sitting up and sitting up in memory and eating the memory. But if we see, we are only seeing here 52 elements. Other elements we don't need to actually calculate them, actually make them, because if they are not getting seen on the screen, then there is no need to compose them. Whenever the user scrolls, then only we can compose them and we can show the user. But this behavior is not supported in normal column. It will render all the elements which we have already uh, already inserted here. So this is the behavior of column, and which is not optimized. Here we are now iterating, we only have a simple text composable. We might have a large cell here, multiple composables here, and the number quite be a big large, or 10,000, 1,000 or 10,000 as well. So 10,000 composables sitting in the memory, that is not a good approach. So that's why lazy column has been invented. So if you have worked a bit with the XML, then we had a list view, and then it came recycler view. So list view used to do same thing which this column is currently doing, but then recycler view came as an improvement which lazily loads the items and only loads the things which are visible on the screen, and then recycles the containers by only changing the data. So user don't see any difference in the UI, but it was actually recycling behind the scenes. So it was optimizing the performance and optimizing the memory usage. So it does the same in case of here in Jetpack Compose. So we can also say recycler view, sorry, lazy column is an equivalent of the recycler view in Compose. So let's try implementing this lazy column. Lazy column. Okay, we just need to import this one, but it doesn't work that way because this lambda is of non-composable. Okay, and we cannot directly insert any composable function here. So that's why we have given here items. Let's say I wanted to do same thing now here. So what should I do? Here we have an items function, and here we can pass a count here. So I'll just pass 100, so that is a count, and I'll just write this composable here, the same element $I, or we can get an I from here, which is a element. And yes, we are now able to see all the elements here, but though we are only seeing the element 51 here, but behind the scenes only 51 elements are drawn or actually composed. The other elements are not composed yet. This is a lazy behavior, and as we go scrolling, we are also able to scroll this. As we keep on scrolling, it gets recycled. We don't notice it gets recycled, but it actually does. So this is the same behavior which we want to achieve with the help of recyclerview in XML, and it is the equivalent of the equivalent is a LazyColumn. But in the XML, if we wanted to make the recyclerview, then there are a lot of things that we need to do, like creating a separate XML file of the layout, then creating adapters, then setting up the layouts, linear layout or vertical layout or other layouts as well. But Compose does all these things with this simple lazy column. It has taken off the burden of our developers by implementing this lazy column. So that's why this is the one of the thing that makes me fall in love with the Compose. So this is the same behavior as the recycler view. This is the optimized behavior, and we are also able to scroll this one. Now, other thing I wanted to show you that just like these items, we also have the single item here. So what's the purpose of this? Let's say if we have all this list, and at the end of the list, we just wanted to notify that this is an end of the list, and we want to add a single composable there. So that's where we can use this. I'll implement here reached end of list, and let's give a modifier here. Modifier equal to modifier dot background. I'll give a background as a color dot maybe yellow, yes, and also dot fill max width. And now if we scroll let the rendering finish. Yeah, the rendering is now finished. And now if I scroll to the bottom, then you can see here reached end of the list. Let me zoom out a bit, and yes, you are able to see reached end of the list. So this single item I wanted to append without disturbing this existing list. If I want to do something like this, then I can do with this single item. Restoring it here. Okay, and the next thing I wanted to show you here is it has a few properties, like before that I also wanted to show you that there is a thing called as sticky header in our lazy column. So sticky header is does the same thing. It sticks, it is a header, thus it sticks the top of the screen while we scroll it. So for that I'll just duplicate this list, and yes, here I'll just write element 100 plus I. Okay, in the sticky header I can use any composable here. I'll again use the sticks composable, rather I'll copy paste from here, and here I'll list this is sticky header, and here I'll make it as a red background. And for this it is showing an error because we need to opt in for the experimental foundation API. So it will only annotate it like this and will allow you to use the sticky header. So now rendering is complete, and I'll scroll it here. After our 100 elements, you are able to see here this is the sticky header, and this behavior is same, but the behavior start at this stage. So you can, if you can see, I am able to scroll the elements, but the sticky header is still here. That's why it is the sticky. When it comes, it gets stick, and when it reaches the top, it sticks there. So the application for this can be most common application for this, like a dictionary application, where we have words starting from A, B, C, and D, and let's say this section starts with A, so we can block a letter here A. So all the words coming under here will be starts from A, and while we are scrolling through the different words, we are still able to see the sticky header that we are in the A section. So that is the one of the benefit that is coming to my mind for one of the use case that we can use this stick header for. So this is one of the thing. Again, I also wanted to show one more thing. Here is a reverse layout. So if you just set it as a true, then you can notice that the recycler view will start the elements from our bottom. So if you can see, it will first show the reached end of the list, then it will start from the element 199 and it will go all the elements downwards. You can see the sticky header now is sticking at the bottom as we are expecting, and here is ends at the element 0. And again, just like the normal column, we also have here horizontal and vertical arrangements. So we can also pass this vertical arrangement dot. But as this lazy layout has a lot of height, then this this arrangement things doesn't make much sense. If it has a static height and a limited number of elements, then only this will take effect. But one thing we can use here, that is a spacebar. So we have a spacebar here, and we can just write 16.dp. Then I just import it. Then what will happen? It will give 16 dp space between every two elements, between two elements. So if you want such a behavior that the list should have separated by some kind of space, then you can use these attributes. So that's pretty well about the lazy column. But if there is a lazy column, then of course there is a lazy row as well. So we can just write lazy row here. Just need to implement this, and this vertical arrangement won't be here. Here it will be a horizontal arrangement. So as soon as I do these changes, then all the list is as it is, but it has a horizontal scrolling behavior. If you can see, I'm able to scroll horizontally, and if you can see, the sticky header will still do the same work here as well. And as this list is reverse, that's why sticky header is sticking right, generally it will stick to the left. So now the elements, I have removed that attribute, and now the elements are now starting from the 0 in the increasing order. And here let us face the stick header. Yeah, and the stick header is now sticking to the left one. Okay, that's it for the now lazy row and lazy column. Now let's move towards the lazy grid layouts. And here we have vertical and horizontal grid layouts. So let's first see the, let me solve this interactive mode, and I have created a separate lazy grid demo class. Here I have created a separate function lazy grid practice, and here we will be practicing the lazy grid. So as usual, I'll first write this. I already created the function. Now I'll first write lazy vertical grid, and it has one mandatory element. So I'll talk about it a bit few minutes later. First, what I wanted to do, I'll take one box here. Before that, I also have to do the same thing with the items, and I'll make a count as 100. So that is the same about lazy columns and lazy grid. So as we know, grid is both about horizontal and vertical. Means it is a lazy vertical grid. That means it can be scrolled vertically, but it can arrange multiple elements in a single row and in a multiple columns as well. So this we can call as a grid. And here for all items, I just wanted to make one box here. So that box should, I'll pass a modifier dot give it a one size dot 100 dp. As I'm giving a size, so that means both it will have a width and height both as a 100 dp. And I also give it a background. So that color can be, I cannot give a one color to all the counts because it will look through. So I'll give a random color here. So I'll just write random dot next int, and it will make a different color. I think okay, that's fine. And here that is a attribute, it is as a no value passed for column. So that is one column attribute, that is it is a vertical grid, but how much elements, how much column do you want in a single row, that's we need to pass. So if we hover on this one, what it takes a grid cells. So I'll just add grid cells dot, we have a three types here. So I'll explain all three of them. First one, I'll check on fixed. So I want fixed columns, that is we need to give a count 5. In a single row I want fixed columns of a 5. So it will arrange accordingly, and it will not show immediately because we haven't applied a modifier to fill max size on this lazy vertical grid. So let's apply this modifier equal to modifier dot fill max size, and as soon as I do that, you will be able to see a great UI here. Oh, something got wrong. Okay, let me check what went wrong. Random doc next int. Okay, and fill max size, that is fine here. We are only okay. Yeah, the UI was showing correctly, but our preview was resume level. Okay. Now, if you can see, it seems a cool UI, right? So, and if you can see, there is a 5 elements here: 1, 2, 3, 4, and 5. If as we have given a count as a 5, fixed count as a 5, that's why in a single row there are 5 columns we are getting. Now this is the behavior we are given by the fixed. But if you can see, if you can I'll just zoom it a bit, little bit here. Okay, so I have provided a size for this box. Each of this is 100 dp. So size means I want this box both width and height to be of 100 dp. But if you can see, there are not squared shape. It has height as 100 dp, but width is not 100 dp. Why? Because as we have said, use this attribute, we are telling that lazy vertical grid that no matter what happens, I want fixed count of 5 elements in a single row. So if it doesn't, if but it says okay, I can do that, but I have to deal with the different width. I have to manage the width accordingly. I can't give you 100 dp for each of them. So, and we are if we are choosing this attribute, then we are agreeing with that. So that's why it is automatically adjusting the width. It is keeping the same height, because for the height it don't have any issue, but for the width it is now choosing it accordingly as per the count we have given. So if you have increased the count here, let's say we have done is 50, then you can see the change here. No matter how small the width gets, it will still try to manage all the 50 layouts in a single row. And as we have all the 100 counts, so there are only 2 rows here, because each of 50-50. So that is type of behavior fix provides. Now let me restore this one, and let us move towards another, that is a fixed size. And it doesn't ask for a count, it asks for a size here. So earlier we have it has the vertical grid has automatically managed the width as per his convenience and as per our count we are given by us. But now if I said head here that I want a fixed size of each of this layout to be of the 100 dp, then you can see the layout has been changed, because we have we have forced it to use this same size. So each of the layout, each of the box here is of 100 dp. No matter what happens, this is the non-negotiable requirement. And that's why if the 3 boxes are fitting here, but if the fourth box doesn't fit here, it has moved toward the next row, but it has kept this full space empty. So if it is not getting fixed here, then just move it towards the next row. This is the behavior of the fixed size, because size is the preference here. Size is given the most importance. If it doesn't fit here, then it will be moved further. That is the behavior provided by our fixed size. And this last one is adaptive. Okay, if we have chosen this adaptive, then we get rid of these spaces. Now let's see how. Okay, we have this thing, we have this block of 100 dp, this block of 100 dp. But if you look at this block or box, then you can see it is a slide, it has a slide as larger width than the 100 dp. We cannot measure, but we can see by our eyes that it has a bit larger width. And why? because it is adaptive. It will adapt accordingly. It will keep uh, all the further boxes as per this width. But if this something space like things happens, then what it will do, it will it will not leave any space and it will adapt accordingly. For the last element, it will adapt its width accordingly, so that no empty space will be left there. So this is behavior provided by the adaptive. As its name suggests, it is adaptive. So these are the three main things that grid cells provide us, and this was the main one of the important things that we need to understand. Now if I open the interactive mode here, then of course we are able to scroll this. There are 100 boxes here, so we are able to scroll it. No issues with that. Now we can do one thing to make it a better UI. As I have already talked about this arrangement, as this is a lazy row and lazy column, this is also a lazy grid. That's why it also has this space by attribute. So we can just write vertical, sorry, not modifier, vertical arrangement. We also have this arrangement dot, again spaced by, let's give it a size of 16 dp, and you can see we get a 16 dp space vertically. Yes, between the rows. And if you want it in the columns, so we can do that with the horizontal arrangement. Same arrangement dot spaced by, and we get this 16.dp. And you can see we again have a nice effect here. So my interactive mode is not on. Interactive. So this seems a bit cooler than the one which we have without space. This with space does a good job of displaying. So the use case we can use it here, like if we are going to build some type of gallery application, then that type of UI, if comes to us as a requirement, then we can use this vertical grid with the space here. So this is the use case that is coming to my mind right now. Uh, so that is about the lazy vertical grid. So as this lazy vertical grid, it is we are able to scroll it in a vertical direction, and also there is an lazy horizontal grid. Nothing changes with this one, only this changes. For the vertical, it is asking for the columns, and for the horizontal, of course, it will ask for the rows. If we keep the value same, then we can see nothing much is changing. Only the thing changes in the scrolling. We are now able to scroll it horizontally, not vertically. So this is the main difference between lazy horizontal grid and lazy vertical grid. Now, if we are able to see all this, all the modifier, all the boxes have the same size, but there is one more layout which we can also talk about, that is a stagger grid. Means even if the layout these boxes have different size, then also we can accommodate that in our one layout. Let me write lazy vertical staggered grid. So if you can see it here, then we don't give it a row, and here it doesn't have vertical arrangement, instead it have vertical item spacing, and it directly takes this dp value. Okay, and the horizontal arrangement, okay, what's the issue here? The value pass for columns. Okay, so it needs further of that, it needs a column, so we can also pass that. What it is taking, staggered grid cells. Okay, takes a staggered grid cells dot, again we have three options: fixed, adaptive, and fixed size. I just keep it a fixed, the 5. Okay, yes, now we cannot see a much difference here because all of the boxes have the same size. Let me randomize the width as well, sorry, height. I keep the width as the same, and I change what happened here. Okay, need to input, and I also want to change the height. So in the height, I'll just write height equal to random dot next in, and in the range 1 to 200. So it can pick any value in range 1 to 200 and we'll append it with .tp. Okay, what happened here? Import, need to import the extension. Okay. Now, if you look at this one, this looks a bit more cool, isn't it? So this is the one of the thing which we see somewhere on social media, like such posts are arranged in a staggered manner. So this is also one of the beautiful thing that we can design our UI. And look at the power of Compose. We have this cool UI with just these few lines of code, nothing else. So this is the power of Jetpack Compose, and that's why everyone is now shifting to the Compose. So that's how we can do it. And as it is lazy vertical staggered grid, there is also a lazy horizontal staggered grid. So it does all the things same. It just, you can guess, yeah, it will scroll vertically. Okay, I need to change a lot of things here. So but it's better that to leave up to you as an exercise to try this lazy horizontal staggered grid, and you will be able to see the same effect, but you will be able to scroll the in a horizontal direction. Let me undo this one. And if you want to again modify a bit more UI of this one, then what we can do, we can clip it to a specific shape, that is rounded corner shape, and give it a height of 16 dp, sorry, corner width of 16 dp, and you will be able to see a more cool effect, isn't it? This is the one more cool effect we can get. Like you can play around with a lot of these items and lot of these layouts by combining this, and you can be there is no sky is the limit for the creativity. So that's it for this today's video. I hope now you have clear understanding about the lazy layouts in Jetpack Compose. So if you still have some doubts, you can put your questions in the comments box below. I will try my best to answer those. If you like this video, then please click on like, share with your friends, and don't forget to subscribe to this channel so that whenever new video with the Jetpack Compose will be published, you will be get notified. We'll meet in the next tutorial with some another interesting topic. Till then, goodbye.